Welcome back. By now, you have learned Python and SQL, two essential skills for becoming an AI engineer. But there is one topic that scares almost every beginner, that is mathematics. The moment people hear AI requires maths, many give up before they even start. They imagine solving huge equations or studying advanced engineering mathematics. But here is the truth. You don't need to be a math genius to become an AI engineer. What you need is to an understanding of a few core concepts and more importantly, knowing why those concepts matter. Think about it this way. Imagine you are driving a car. You do not need to know how to build the engine, but understanding how the steering wheel, brakes, and accelerator work helps you drive safely. Mathematics plays the same role in AI. You don't have to derive every formula, but you should understand what the algorithms are doing behind the scenes. The four main areas you need are like linear algebra, probability, statistics, and calculus. Linear algebra helps computers understand vectors, matrices, and high dimensional data. Every image, every text document, and every machine learning data set is represented mathematically using matrices. Probability helps AI deal with uncertainty. Whether it's predicting tomorrow's weather or determining if an email is spam, probability helps estimate the likelihood of different outcomes. Then, statistics helps you analyze the data, identify the trends, and evaluate how well your models perform. It's the backbone of the data driven decision making. Finally, calculus is used to optimize machine learning models. During training, algorithms adjust themselves repeatedly to reduce errors, and calculus provided the mathematical tools to make those improvements. The good news, you don't need to master these topics overnight. Learn them gradually while building the projects, and they will start making practical sense. Now let's break down these four mathematical topics into simple concepts. First, linear algebra. Linear algebra deals with vectors and matrices. Imagine a spreadsheet filled with numbers that essentially a matrix. AI models use matrices to represent data sets, images, videos, and even words. Learning matrix, multiplication, vector operations, transpose, and eight values given you a strong foundation for understanding the machine learning and deep learning. Next come probability. Probability answers questions like how likely is the event to happen. AI model consistently make predictions with uncertainty. For example, an image classifier might say there is a 95% chance of the picture contains a cat. That probability in action. The third topic is statistics. Statistics help summarize and analyze the data. Learn concepts like mean, median, mode, variance, standard deviation, correlation, and distributions. This helps you understand whether your data set is balanced, noisy, or biased before the training any model. Finally, calculus. Calculus is mainly used during model optimization. Algorithms like gradient descent repeatedly adjust parameters to reduce the prediction errors, while libraries like TensorFlow perform these calculations automatically. Understanding the concept helps you troubleshoot and improve the models. Here is the key takeaway. You don't need to solve hundreds of mathematical proofs. Focus on understanding the intuition behind those concepts. Once you combine mathematical knowledge with the Python programming, machine learning becomes much easier to understand. Let's build a simple learning plan for mathematics. Week 1, start with basic linear algebra. Learn vectors, matrices, matrix multiplication, transpose, and matrix dimensions. Visualize these concepts instead of memorizing formulas. So, in the week 2, move to statistics. Understand the mean, median, mode, variance, standard deviation, probability distributions, and correlation. Practice using real data sets in Python with pandas. Week 3, learn probability. Study conditional probability, uh, Bayes theorem, random variables, and probability distributions. These concepts appear frequently in machine learning algorithms like naive Bayes. Okay, then in the week 4, learn basic calculus. Focus on functions, derivatives, gradients, and optimization. Do not spend months on advanced calculus unless you are pursuing research. Your goal is to understand how machine learning models reduce the errors during the training. Remember, AI libraries perform most mathematical calculations automatically, but interviews often test your conceptual understanding. So, if you know why an algorithm behaves a certain way, you will perform much better than someone who only memorized the code. Another important tip, learn math alongside programming. When you study matrices, implement them in the NumPy. When you learn statistics, analyze the real data sets with the pandas. This practical approach makes you learning easier and more enjoyable. You have now completed the foundation of your AI journey. So Python, SQL, and mathematics. These three pillars prepare you for the most exciting part of the roadmap. In the next video, we will finally enter the world of machine learning. You will learn what machine learning really is, the different types of algorithms, and how models learn from the data, and how to build your very first AI prediction system. Keep learning and also consistent in your learning. Every concept you master today brings you one step closer to becoming an placement ready AI engineer.